is equal to 0. To solve that quadratic equation, which we reviewed on day 1, okay, you could either try to factor, this is a difference of squares, x plus 2x minus 2. Or you could use the quadratic formula where a is 1, b is 0, c is negative 4. Those are really intense ways of solving though. Or we could even do the square root method, which is what I prefer. Get x squared by itself equal to 4, and then x would equal plus or minus the square root of 4, which is 2. So those are my two x-intercepts at negative 2, 0 and positive 2, 0. Okay. So that's what's happening. We could show those on our graph if we wanted to. So here is at 2, here is at negative 2. That's the situation, my x-intercepts. For my y-intercept, I would let x equal 0. Letting x be 0, 0 squared goes away. We just have negative y minus 4 equals 0. But moving y to the other side, as a positive y, we would have y equals negative 4, wouldn't we? So the y-intercept is just 0, negative 4. In other words, down here. And we talked about how this is a parabola because x is being squared alone. So this is a parabola opening up. We can see the beautiful symmetry, I hope. What kind of symmetry does it look like? It definitely looks like y-axis. But if you hadn't drawn the picture, if you didn't remember that, you could have used these principles, right? And so again, if you drew me the perfect picture, then use that, that's fine. But you should know these principles also. So to check these two, we change the sign of the x's. Yes, ma'am?
Okay, when you move the y over,
yes,
it can become a positive y? 4?
Well, I didn't move the 4. I could have. If I chose to move the 4 and left the negative y there, I would have negative y equals positive.
Oh, so you see after the divide.
Yes, ma'am. That's it. You got it.
All right.
Good question. Now, when I change the signs of my x's in this equation, this would become negative x getting squared minus y minus 4 equals 0. But squaring, as we mentioned, any even power of a negative is positive, isn't it? So that's still x squared minus y minus 4 equals 0. The question you ask yourself for y-axis, is it the same? For origin, is it opposite? And you mentioned it, you're right, it is the same, isn't it? This is the same as the original. Since it's the same as the original, we can declare with confidence it's y-axis symmetry, which means it's not origin symmetry because it's a function. Therefore, it can't be this one because it's a function. If you had chosen to show your work, you would have changed the sign for this one of the y, wouldn't you? And if you had changed the sign of the y, what would have happened is you'd have x squared minus a negative y minus 4 equals 0. What does that mean? Well, this one changes. It's changing to a positive, so that changed. But x squared stayed the same, negative 4 stayed the same. And what we're looking for x-axis, after you make this change in y, do you get the same thing that you started with? And this answer would be no, because this guy changed, didn't he? Okay, so you can prove it all 3 cases, or you can depend on the graph being a function. And as you go forward, you don't do this every single time. But you do need to show me on this test that you know